All right, so this is the first video that we need for Math 105. And this is a review material. The first five lessons on your syllabus approximately are about review material from the past. You might be rusty with math, but we're going to go a little bit quicker with these review material until we get to 1.1, 1.2, etc., where we hopefully will slow down. Okay, but here goes. The topic is as follows. We have to learn about it's the topic that we need to do is integer exponents. So let's see. Let me get my pen and let's get started. So my pen, it looks as follows. Integer exponents is our topic. And let me give you the fundamental four. There's really fundamental five, but these four are even more important. And let me put them down and make a big fuss over the first four rules of exponents. The first one is you have the same base, x to the 4, times another base, the x. It's the same base, x and x. They're both the same base. That's crucial. If they're different bases, it doesn't work. And if they're the same base and they're multiplying each other, so then you add the two exponents together and you get x to the 6. All right, what if you got, again, the same base? It's key that they be the same base. Right here, this is called the base. The x is the base, and this is the exponent. Base, exponent, base, exponent. That's the vocabulary. All right, what if you have x to the 5th, this time divided by x to the 3rd? Okay, so what you do is you take the top number, 5, the top exponent, subtract the lower exponent from it. 5 minus 3 is 2. And you get x to the 2nd. Extremely important two rules. Third rule, if you have x to the 4th, I'm choosing the same numbers as number 1, x to the 4th, all of that take to the 2nd power, so you don't have like number 1, you don't have an x and an x, you just have one x, power to a power. Then you multiply and you get x to the 8. Notice the difference between problem number 1 and problem number 3. They both have a 4 and 2 there, but one you add them and one you multiply. Power to a power, you multiply. Here comes the fourth most important. What if you have a negative exponent? You can always change it into be a positive exponent and get rid of any negatives. Here's what x to the negative 2 is equal to. 1 over and then dump the x, the base, dump the power 2 without any minus there into the basement there, and you have 1 over x to the 2. Those are the final answers for those four questions. These are super fundamental exponent questions. There's another really important one, number 5, which is anything taken to the 0 power is equal to 1. And one more pretty important one, if you have anything that is the taken to the 1 power, let's say you have in parentheses 51x taken to the 1 power, it's going to just be itself. Anything taken to the 1 power is itself. So it's 51x. All right, so the first four are super important. The second two are pretty important. Now, let me give you a bunch of questions. Some of them turn into trick questions. That's what we need to do. You have to expose you to some trick questions too. All right, what if you have as follows? If I give you 51 to the 0 power, here's where that's question number 1. Let me go up here, do problem number 8. Problem number 8 over here. And what if you have, as follows, not 51 to the 0 power, but you've got negative 2/3 to the 0 power. That's another question. And what if you have problem number 9, you have negative 5 in parentheses to the 0 power. And here comes a trick question. You have negative 5, the same exact stuff up there, but no parentheses, negative 5 to the 0 power. Okay? Now, so I've just given you 4 questions that I didn't answer yet, but let's answer them right now. 51 to the 0 power is 1. Negative 2/3 to the 0 power is 1. Minus 5 to the 0 power is 1. Now, let me slow down. That's because the 0 power applied to the entire contents of the parentheses. That's different here. The 0 power applies only to the 5, not to the minus. And therefore, you do this in 2 steps. Hopefully this sounds familiar from the past. I'm putting it up here in the upper left-hand corner. PEMDAS. But there's power. No, I'm sorry. I apologize. I need to do it in vertically. So first comes the parentheses, not power. Then comes exponents. Then comes, sorry, I'm a little bit rusty from the summer. M and D is multiplication and division. They're on their same level. And then last in the hierarchy is addition and subtraction. Hopefully this sounds familiar. So what if you have an exponent versus a multiplication? Who goes first? Answer: exponent. Whatever comes first in this vertical thing here is what comes first. So the parentheses comes first. Parentheses comes first, then exponent, multiplication, division on the same level, addition and subtraction on the same level. All right, having said that, so what do I have over here? I've got I've got an exponent, 5 to the 0 power with a minus. First two 5 to the 0 power, which is 1. And then the minus kicks in, and the answer is -1. So there's a big difference between problem number 9 and problem number 10. They have 2 different answers, even though they look the same. The parentheses makes all the difference in the world. That's the point I'm trying to make there. Okay, let me show you some more stuff. What if you have, let me give you one more trick question, very similar to number 10, but might as well get rid of it right now. I think it's worth doing. -5y to the 0 power. How would we take care of a situation like that? So again, you've got a exponent thing going on over here, and you got a multiplication going on. An exponent wins, so first do the exponent, y to the 0 power, which is 1. I'm going to surround it by parentheses for clarity. Then comes the -5, which is trying to multiply the y to the 0, but y to the 0 is equal to 1, so -5 is trying to multiply the 1. And what do you get at the end of the day? -5 times 1, which is -5, and the problem is over. Okay, now let me show you some more stuff, important stuff. What if you have number 12? It looks as follows. You have x to the 7 times x to the -5. Now, I emphasize the first 4, really important, right? Number 5 and 6 also important, but not as important as the first 4. Which one of the first 4 does this problem number 12 match? Which one is an analogous to? What does it connect with? Problem number 1. There's a power x, they're multiplying each other, and they each have exponents. So what does number 1 tell us to do? Add the exponents together. Let's do that. Add these 2 exponents together. 7 and -5 is 2, and therefore the final answer is x to the 2. The rule works no matter what, even if there's negative numbers in there. Number 13. What if instead of an x, I throw a curve at you and I put a 5 in there? And I don't want you to use a calculator, so if you have 5 to the 3 times, let's say 5 to some ridiculous number, 5 to the 11, we don't need a calculator. We're not interested right now in a calculator. So you have the same base 5, the same base 5, 2 exponents. You add them together. There's a multiplication going on, just like problem number 1. You add them together, it becomes 5 to the 14. The same rule number 1 applies yet again. All right. How about if you have something like problem number 14, where you have x to the 5 over x to the 8? What is this analogous to? Problem number 14 of the first 4, the fundamental 4. Which does 14 look like? It looks like number 2. Okay, so that means we do a subtraction. Just like in problem number 2, we did 5 minus 3 is equal to 2. Over here, we do 5 minus 8, which is equal to -3. 5 minus 8 is -3. So the answer is x to the -3. On most answer sheets, and on Alex, you will probably not see x to the -3. They will want you to change this into using rule number 4, the problem number 4, rule number 4, 1 over x to the 3rd. That is the final answer that they'll want to see on your answer sheet. Because what is a negative exponent can always be turned into positive. Just dump it in the basement. dump x to the third into the basement, x to the third, 1 over x to the third, is the answer. All right, we got some more room on the paper. I really can move the paper up and down, but let me not do that right now. Actually, I will. Let's do that. Let's move it up a little bit. There we go. All right, we can still see basically number 1 through 4. One's a little obscure. But here we go. Let me ask you this question. What if you have x to the 4 times y to the second? Let me give it a name, number 15. And what if you have x to the 5 over y to the 3? Y to the 3. Those are the two questions. Well, if they're not the same base, they don't match, then you have nowhere to go. The final answer to this is x to the 4, y to the 2. The final answer to this is x to the 5 over y to the 3, because there's nowhere to go if the two bases do not match. The rules that we did over here in problem in 1 through 4, the rules that we gave out were all where they matched, except for number 4 where we were looking for a match. Okay, so now, if we try something a little bit more complicated, which is very, very possible they're going to be throwing at us, something a little bit more complicated. What if they try this on us? Number 17. 5x to the negative 8, y to the second. Y to the second. How would we handle that? All right. So here's the story. The 5 is, there's going to be, if you see that minus there, you pretty much know almost all the time that there's going to be a fraction bar, right? Just like we see in number 4, but look back to number 4 when we had a negative exponent that created a fraction bar situation. For this negative tells us we're pretty likely to have a fraction bar situation. So what numbers belong up there in the numerator above the fraction bar? And what numbers belong in the denominator below the fraction bar? All right, 5 is regular positive. It belongs above. Y to the second is regular positive. It belongs above. But what happens to x to the negative, next to the negative 8? Scrap paper. Let me just show you in scrap paper what happens to next to the negative 8. It becomes 1 over x to the 8. So this 1 would be on top. I don't need that 1. Right? 5 times 1 is 5. Why do I put a 1 there? I don't bother. I'm just going to put the x to the 8 in the denominator right away, and this is what the final answer looks like for problem number 17. Okay, well, these videos can't be too big. They go to YouTube. They got to be under 15. So I got to end this video pretty soon at least. Might as well end it now. Okay, here we go. Second, where is my